All of you able to record now. So this is majorly hierarchical database system and the drawbacks of the hierarchical database system, right? Madhu,
Yeah.
Raja,
Muted.
or this hierarchical.
Yeah, Srinivas.
Here, internally data is not straight away stored in the form of table. Internally, data is not stored in the form of table straight away, right? Okay. So internally data is stored and organized in these logical structures called a tree structure. That tree structure is what? Hierarchical database system. Okay. But here comparatively file-based system, the hierarchical database system can read the data faster. Number of IO operations are reduced. Okay. It is optimized. But still there are these drawbacks. So to overcome these drawbacks, next network database model is got introduced. To overcome these drawbacks, next network database model is got introduced. Right. In the network database model, we have a network model architecture. Here you see every node is connected to every node in the database. Node 1, node 2, node 3, node 4. So every node is connected to every node here. See like this. This is a network connectivity or network architecture, right? Of course, when it is something 4 nodes or 6 nodes, it looks very nice. See here, salesman and product. So one salesman sell all the products. So a product might be sold by multiple salesmen. Okay. So this kind of storage mechanism, store and organize the data is what? Network mechanism. If you understand, the hierarchical database system follows internally one-to-many relationship. This network database system built on many-to-many relationship. This network database system built on many-to-many relationship, right? Just observe here. If the database, this network database system is really good database system, what was built on, it is eliminated all the drawbacks of the file-based system and network database system. All the drawbacks was eliminated. Okay. But here still there is a drawback, that is this network database system is highly suitable and comfortable for small databases. And the database is small in size, it is highly comfortable. Okay. It's not suitable for large databases. It's not suitable for large databases, right? Okay. Why? Because here the relationships itself will become complex. Whenever the database sizes keep on increasing, complexity of the data gets increased. Complexity of the data gets increased. Because whenever the data size is increasing, the relationships also will be increased, right? Because every node must be connected with every node. Okay. So network relationship we are maintaining Due to this network relationship, these relationships themselves become complex, right? These relationships themselves become complex. So this is the major problem. So performance of accessing the data with the large databases is really become problematic. So when the database size is increasing, complexity of the data gets increased. Complexity of the data gets increased. So performance of the database is got degraded. Okay, this is the major problem with network database. But accuracy wide and redundancy wide and everything is good. The network database model is really good. Only the drawback of the network database model is its accuracy. Sorry, its performance. It's only suitable for smaller databases. When the database size is increasing, automatically performance of the database gets degraded. Okay, it's only fit for small databases. So this is what about file-based system and hierarchical database system and network database system. Finally, the solution came up with a relational database system. Finally, we came up with a relational database model. In relational database system, remember first point, data itself stored in the form of table. Please remember and identify that. In the network database system or hierarchical database system or file-based system, data is not straight away stored in the form of table. Data is not straight away stored in the form of table, right? That is internally organized using data storage structures like something like structures, linked lists, and trees, binary trees. These kind of concepts they have used. They maintain like that. Okay, but here in the relational database management system, data is stored in the form of table. Simply remember, data is stored in the form of table. First thing. Then the tables maintain relationships. Here you see we have three tables: author table and publisher table and books table. In the author table, I have an author ID which can be useful for uniquely identifying the author. In the publisher table, I have publisher ID. In the publisher table, I have publisher ID. So author ID and publisher ID both are having in the we have in the books table. So these are related, right? So books, the book ID, something like who is the author and who is the publisher and date and what is the title of the book. Like this, the complete information I can get from if I am able to access this table and go through the relations and join the data, right? So this is the tables themselves maintain relationships. Okay, data gets stored in the form of table, and these tables have internal relationship, that is one-to-one relationship or one-to-many relationship or many-to-many relationship. It organizes this kind of database model is a relational database model. So when you are understanding relational database models, how the data is actually gets stored in these databases, you have to understand these various levels of views. So if you understand here, this is user 1, this is user 2, this is user 3. User 1, user 2, user 3, right? This is user 1 schema. This is user 1 schema. User 1 schema means this is the accessible area for the user 1. It's a user 1 database. So this is user 2 database. This is user 3 database, right? So all the tables, those are created and accessible to user 1, they appears here. All the tables, those are accessible to user 2, they appears here. All the tables, they are accessible to user 3, they appears here. This is external level. This external level is user accessibility level. This is an user interface level, right? Okay. So here the next one is conceptual level. So conceptual level contains conceptual schema. Conceptual schema means what is the table name, what is the column name, what is the data type of the column, what is the length, how much memory required. Okay, this kind of conceptual schema, that is a conceptual level. And next one is physical level. So what is the record size? So how much memory is required for a record? Then for the first column, how many bytes are required? What is the offset position? Okay. And next one is what is the actually second column, where it begins, what is the offset position, how many bytes. So memory occupation structure, the physical memory occupation structures will be available in internal level. Then actually it goes to store in the database, right? Physical database organization. So then actually it goes to store in the database. All of you clear about it?
Srini, can you come again on conceptual level once again?
So in the user view, you will see table and data. Okay, Madhu? Sorry, Raja.
Yeah.
In the user view, you will have table and data. You will be able to see the table name and you will be able to access the data from the table. Of course, you will be see column names also. That's what really user is required for accessing data from a table, right? Clear?
Yeah.
But in the conceptual schema, we will have what is the column name, what type of data that column is dealing with, what length of the data, what is the length of the data, that kind of information, right?
Okay.
So each column required how many bytes memory, it knows that. It knows that what type of data it is dealing with. That is what conceptual schema.
Okay.
Accordingly, physical schema says that how many bytes memory is required, what is the offset position. So from that position, how many bytes, up to what memory block it is occupied, right?
Okay.
So internal physical schema is what memory occupation related, physical memory occupation related information. Got it?
Yeah.
Just you see here, this is user 1 view, this is view 1, means table 1, let you understand table 1. We have code and name. This is table 2, we have branch code, name and salary, right?
Yeah.
Are you clear? Table name and column names you can see, you can access the data, right?
Yes.
This is the conceptual level. You have code is the column, this is character, occupies 6 bytes. Branch code is the column, it deals with characters, occupies 6 bytes. Name is the column, it deals with character, it occupies 20 bytes. Age is the column, it is the numeric, it occupies 3 bytes. Okay, salary is a column, it is numeric, occupies 6 bytes, right?
Yeah.
Then once you go through the physical layer, so total employee record, this total information stored employee length is 43 bytes is required totally. One record required 43 bytes, right?
Mm-hmm.
So here code is occupying 6 bytes. Offset position 0, right? Then branch code required 6 bytes. Offset position for 6. So 0 to 5 given for code. Then 6 to 11 is given for branch code. Then name required 20 bytes. Offset position is 12. 12 to 31 given for name, right?
Yeah.
So age required 3 bytes. It is starting from 32nd byte. So 32 to 34 given to age. Then salary required 6 bytes. So 35 to 43, right? Total 6 bytes it is occupied. So this is how the memory allocation is done. This is what internal physical level. So accordingly, it occupies the memory, it prepares the structures and occupies the memory. This is generally every database will have this kind of layers and this kind of memory management and memory occupation structures. But whereas exclusively we are talking about Oracle, let me understand about Oracle internal storage mechanism. So what is behind the screen? Okay. So already we know that here database users, otherwise the applications, those access the database, your programs access the database, right, or tools. So everyone can access the database using SQL only. This is the database engine and this is your database management, data storage database, where actually data gets stored in the form of tables. All together is what your Oracle database server. This is your Oracle database management system, or the Rdbms. So the end users access the database, by processing queries in the database engine. So here you will have SQL processing engine, and even PLSQL processing engine also. But this is the database actually. So where do you store your data in the form of table? The table structures will be here. So we do store data in the form of table. So here there is no alternative thought. We are believing and we are learning and we know that and we are believing that data gets stored in the form of table. This is database. In a database I can have multiple tables. Table is in the form of rows and columns, right? But here majorly what we need to understand is this much already we understood. This is user presentation layer level. This is user accessibility level, right?
Yes.
So here we query the SQL. We process SQL engine process the SQL query. It accesses the database tables and it provides the accessibility. This much is done. This much already we know. But behind the screen in your system, how actually this is stored. So here I am saying right from the beginning, here data itself is stored in the form of table, right? But is there any storage structure possible in the computer like table? So in computer we have only one and only mechanism to store content is in files. Understand? Your operating system can store data, can store content in your disk in the form of files and folders. There is no alternative. But here, logically, we are organizing them. Okay, just see here. Here, as per the storage mechanism concern, the most lowest part of the data storage, the most lowest, smallest part of the data storage is data block. Even if you people know about operating system or something like that, easily you know what is data block. Actually here relational database data block is, the Oracle data block is by default 4 times bigger than, the OS data block. So the most smallest part of the data storage is data block. Okay. So here you see this is a data block. So the data block contain header, and also data block contain free, PCT free, okay, free memory. And this is actually used memory. This is the structure of the data block. Every data block will have a header and free memory, right? Understand? So actually the data, this is the straight away unit to store the data. This is the most smallest part of data storage. Like this, we do have multiple data blocks. Like this, we do have multiple data blocks. Okay. So the multiple data blocks together, we say it is a logical structure. Data block is not a physical structure. Data block is a logical structure. Logically, data is organized like this. Okay. So the group of data blocks is what we say an extend. Group of data blocks is what an extend. This is an extend. Group of data blocks is what an extend. This is an extend, right? So here we will have multiple extends. We have multiple extends. Extend 1, extend 2, extend 3, and so on. We do have multiple extends. So group of extends together, we do say it is segment. Group of extends are known as segment. So this is actually we say a segment. This is what actually we say a segment. So data block is a logical structure, extend is a logical structure, and segment is a logical structure. Segment is a logical structure, right? So multiple segments. The multiple segments will have multiple segments. So multiple segments together is what we say a data file. Multiple segments together is what we say a data file. So here please understand, this is a data file. Data file is actually physical storage structure in your computer, because that is a file in your OS, that is a file in your system. This is data file, right? So data file is actually physical storage structure. This is a data file. Like this, we do have multiple data files in our system to store and organize the data, to provide enough memory for your database. We do have multiple data files. So data file 1, data file 2. Each and every data file is a file in your OS. Data file 3 and data file 4 and data file 5 and so on. So all data files together as a group is known as table space. Table space, right? So this is what I say, a table space. So table space is actually the memory for your database management systems. Table space is actually memory for the Oracle database. Like this, not only single table space, you can have multiple table spaces. Table space 1, table space 2, table space 3, table space 4, and so on. DBS do create multiple table spaces. Whenever you are creating table space, the table space contains multiple data files, and data files are internally organized in these formats. But actually, as an end user, we really doesn't look into them. Okay. But these table spaces actually provides memory for your database. Okay, these are the memory. Just like you see Unix operating system. In Unix operating system, you will have only one memory. That is disk, root node. It starts from the root. Even though you have multiple hard disks connected together, but all together it will show like a single memory, right? All of you know about it. In Unix operating system, you doesn't have anything like your C drive, D drive kind of partitions. So entire memory starts from the root. Even single hard disk or multiple hard disks you attach to the system, you will be able to see everything begin from the root. Similarly, here there could be multiple table spaces, but altogether is the memory for your database. Of course, you can specify if you want, please store it in table space 1. For this user, allocate memory into these table spaces. Like the DBA can do something, but as an end user, we doesn't mind about it. But if you understand so far, the table space is the top level one, which is directly provides am a memory. Please take this memory. Like this, it gives memory to the database. But data file, and inside the data file, the segments, inside the segments, extents, inside the extents, data blocks. These all things you have, you observe it is in a hierarchical relationship, right?
Yeah.
Okay. Sindhu, are you able to follow?
Yes, Srinivas.
Yeah.
Yeah, actually I was going to it.
Yeah. Raja.
Yes, Srini.
Yes. Swati. Naveen, did you join? I think Swati is joined today. Naveen is not joined, I think. Okay. Madhu.
Yes, Madam.
Yeah. So now you are able to identify database, the database table spaces, table space to table data file, then segments, extents, data blocks. It is in a hierarchical structure you observe, right? Here, the relation between data blocks also can be maintained, because some data is stored here, some data is stored in the another data block of this for the same table. So of course it maintains the relation between the data blocks, one-to-one relation between data blocks. So anyhow, internally these kind of relationships are established, but as an end user, as a database user, of course we understood these all things, but really we are not going to work with these structures, whatever we discussed so far. Okay. Just for understanding purpose, We know that database, the table space provides the memory for the database. Table space actually provides memory for the database, right? So inside the table space, what is there? We don't want. Okay. Anyhow, internally how it is organized, we understood. So these are the table spaces, it provides the memory. So in these table spaces, whatever data you store in the form of table, they get stored in the table only. Of course, the piece of values goes to the blocks, then it goes to the multiple blocks. Multiple blocks maintain the relationship. So this is all together related to one record. Let you understand that is in a segment. Like this, so many segments, let you understand those all are the records. Each and every segment is a record. So an extend is representing a table, right? Of course, this is some guessing kind of thing I am telling you for easy understanding us. Of course, similar kind, but it is a little different if you go deep and understand it. Are you clear? At present, you understand one value stored in one data block. Okay. So one record, like this multiple values, those are interrelated. So here one record goes to one extend. One extend is nothing but one record. One segment is nothing but multiple records, one table. Okay. So there are multiple tables you can have, right? That's what a data file. So there are multiple data files, so it will become the multiple data files and multiple table spaces. So the database become really capable of handling so many tables. Understand? If you understand like this, do you say data is stored in the form of table or not? The physical storage itself in the form of table or not? That is actually speciality and power of the relational database management, Rdbms. Okay. Here anyhow data is stored in the form of table and relationships are maintained. So of course the another way we can say Dr. F. Cord, who is the member of IBM Publications, is actually in 1970s he published a relational theory. So when he published the relational theory, no one is understood. But after that it is redeveloped and everyone is got interested on his relational database theory, and IBM is developed and released their relational processing engine, that is SQL. So totally that is become as common standard. Okay. So the first relational database, commercial relational database management system released by Oracle Corporation. The first relational theory is defined by IBM and SQL is designed and developed by IBM. But the first commercial database management system released by Oracle Corporation. Are you clear? Yeah. So this document actually I will be sending you. So in this document you have the detailed information like what is data, what is information, what is database, what is field, what is record, what is table. Field is known as column, record is known as row, table is also known as, I think, tuple. Okay. So here this is the what is the table structure and the database management system. What is relational database management system? What are the relationships among the data? What's about one-to-one relationship? What's about one-to-many relationship? And what's about many-to-many relationship is available? And file-based approach of database system is available here, is given in description. And what is the Rdbms approach? Database management approach is given here. So what are the main advantages of the database management approach? Integrated and shared is the main advantage of the database. The benefits of the database management system: sharing of data, okay, improvement in data security comparatively file-based system, maintenance of data accuracy, okay, better interaction with the user, and it is an efficient system. But once you understand the database management systems, okay, you'll have the database management system architecture like schema, internal physical level, and conceptual level, and external level. This diagrams related theory is given. But evolution of the database management systems, if you understand, one is hierarchical database model, and next it is a network database model. After that, relational database model. So what's about the relational database model we understood. Then after, in around 1980s onwards, the object-oriented programming concepts are become very popular. Then here database management system incorporated that advanced mechanism, advanced technology into it. Okay. Then actually they released object-oriented database management systems first. Object-oriented database management systems means abandon SQL. Okay, in Hadoop and these mechanisms, you can see some of the ecosystems. Those ecosystems are doesn't use SQL. They'll use their Java program, a MapReduce program. There is no SQL. That's why those things are called as no SQL. That's what abandon SQL. So you will use an object-oriented programming language instead of SQL, but still it is used to store and organize the data in the form of tables. That is DBMS, works as DBMS. So that kind of databases are known as object-oriented DBMS. But most of the ways for organizing the structured data in structured format, it's not really advisable. So next, Rdbms came to the picture. Rdbms means it is relational database management system only. Please remember, when you listen the term Rdbms, ultimately you have to understand SQL. SQL is the common database language for all Rdbms tools. SQL is the common database language for all Rdbms tools. Okay. So it extends SQL capabilities with the object-oriented features. It's having extended SQL. The SQL capabilities are extended to extended with object-oriented features. Okay, this is object relational database management system. So here integrity, security, okay, versioning, and these all relational querying, recovery, okay, archiving, concurrency, persistence, these all are the database capabilities. Then object-oriented programming capabilities like inheritance, data encapsulation, object identity, okay, polymorphism, these both together will be there in your object relational database management system. Okay, so SQL plus OOPS is what actually we say object relational database management system. So this is the document I prepared for understanding the basic relational database management concepts. Okay. All of you clear about this, or do you have any questions?
Yes, sir, it's clear.
Sindhuja?
Yeah, Srinivas. Yeah, I'm clear with it.
Yeah, Raja.
Yeah, I'm good.
So there are only 4 types, or are there any other than this?
What, Sindhu? Come again?
Are there any other types other than these 4, or only restricted to 4?
What for?
The 4 types you are discussing about: hierarchical, relational.
Forget about hierarchical, these all are old. Okay.
So currently
Okay.
it's all based on relational only.
Yeah, just it is evolution. Currently we are using relational and object relational. Nothing. Hierarchical and networking and file based, these all are outdated.
Okay.
Just I told you about history, how the mechanism was grown.
Okay.
Okay, now only remember relational.
Okay.
Yeah. And Raja, Madhu,
Yeah, I'm good, Srini.
Yeah. Swati. Are you able to understand?
Yeah.
Yeah. So then tomorrow's session, I'm going to discuss about database declaration mechanism, entity relational modeling. Okay?
Okay.
Yeah. Yeah, you are going to forward the document, right, Sinu?
Yeah, please, Madhu.
You are going to forward the document, right? Okay.
Yeah, I'm going to send.
Okay. Yeah.
Do one thing, and all of you know, I received some of the mails, I think, but please note down my email ID and send a test mail to me. Okay. In the mail content, you write just your name and the Oracle Rdbms course content, course books like that. So I'll be forwarding these books to you. Okay.
Okay.
So you people please send a test mail to me. So this is my test mail. Okay. This is my mail ID. You please send the test mail to me. So this all even entity relational modeling. So here I have this Rdbms concepts related. I collected this concept somewhere and I prepared these things. So these books are there. So entity relational modeling, one more book I have. Okay, data modeling concepts related. This one, and as well I have normalization exclusively about normalization. Okay, what is normal form 1 and what is second normal form, third normal form, these all. Okay. So then we have client server databases. Of course, these client server databases I am not going to explain. So you please go through this. So what is the desktop databases? When the database systems was desktop databases, how the processing is, and what is the client server databases, client and server, LAN based, and what is the client server databases in entire design, multi-tier client server architecture. This is database server 1, this is database server 2, client 1, client 2, client 3. Any client can connect with any server. The middle tier is organizing. Nowadays the parallel servers and load balancing and everything done in this mechanism. And as well centralized database. This is the centralized database concept. Okay. And this is a network distributed database concept. So this book also there. These all books I will send you. Just give me a second. Hello. Madhu? Madhu. Madhu.
Unmuted.
Hi Sindhu. Hi Madhu. Just you
Yeah.
send me the mail, then see you tomorrow. Okay.
Yeah, sure. Okay.
Yeah.
Okay.
Thank you. Yeah, Sindhu, do you have any questions?
I don't have any questions.
Yeah, Sindhu.
I'm okay with it.
Yeah, Sindhu. Sindhu, if you have anything more, tomorrow session I will discuss with you. Okay.
Yeah, sure.
Yeah. Please forward me, send me the text mail and I will forward the material to you. Okay.
Yeah.
Okay, thank you.
Thank you.
Hello.